Hello, Wade Gibson here along the beautiful Upper Verde River near Paulding, Arizona. I'd like to give an update on the work being conducted here by researchers from Northern Arizona University, which is being funded by the U.S. Forest Service Rocky Mountain Research Station. I'm the team botanist for Ecoculture and a research associate for NAU. Recently, the Bureau of Reclamation, United States Forest Service, United States Fish and Wildlife Service, and the Arizona Game and Fish Department have all come together to propose a project that would assist native fish recovery on the Upper Verde River. Historically, this section of the Verde River was home to many native fish species, including spike dace, loach minnow, Sonora sucker, and the razorback sucker. Today, this section of the river is dominated by non-native fish, which include smallmouth bass, channel catfish, green sunfish, and crayfish. Restoring the native fishery in this section of the river has the potential to increase existing populations of native fish and reestablish populations of endangered fish. The proposed project includes the construction of two concrete fish barriers in the Upper Verde River. A fish barrier is a common tool resource managers use to help recover native fish by protecting streams from upstream invasion by non-native fish. Typical fish barriers are constructed of reinforced concrete spanning the river channel and floodplain. A 4-foot drop combined with a sloping apron prevents non-native fish from moving upstream of the barrier. The design in this picture is not the exact design that is proposed for the Upper Verde fish barriers, but it would most likely be a similar concept. Part of the decision-making process in deciding on where to locate these fish barriers is stream channel stability. You don't want to put these barriers in an area where the channel is unstable, especially in an area where large flood events occur. This is a photo of the Brewer's Tunnel Diversion Dam, located just upstream of Clarkdale, during a flood event that occurred in 2019. This is where our project finally comes into play. In order to monitor channel stability over time, you need to collect certain morphological data at permanent sections along a stream channel. Lucky for us, there just so happens to be around 44 permanently marked stream cross-sectional transects located along the Upper Verde River that were established in 1996 for the purpose of collecting long-term geomorphological and riparian vegetation data. We will be resurveying a subset of these transects during the summer of 2022. These traditional methods, including field weighting surveys, using GPS, total station, or leveling instruments, remain the standard for stream mapping. While these surveys can be highly accurate, they are also slow, labor-intensive, costly, and often done with point measurements spaced more than 1 meter apart in at least one dimension, producing digital elevation models with fairly coarse spatial resolution. However, the prospect of utilizing both airborne and terrestrial light detection and ranging, or LiDAR, to map channel features and detect change over time has generated considerable interest in recent years. The airborne type of LiDAR is a laser scanning system that is attached to an airplane, helicopter, or drone. Light pulses are sent to the ground and measure the distances and the dimensions of the landscape that is below. Terrestrial LiDAR is fixed to a stationary device or a tripod on the ground. This system often scans in several directions with the use of mirrors instead of scanning down. This allows the system to capture data all around. During the spring of 2022, an NAU graduate student and I went out into the field and collected terrestrial LiDAR data along a subset of those permanent transects I mentioned earlier. UAV, or Unmanned Aerial Vehicle, derived LiDAR data is also being collected at these transects. Both the terrestrial and UAV-derived LiDAR will complement each other, since there can be shadows that neither terrestrial-based or UAV-based scanners can scan on their own, as depicted in this diagram. The objective of this project is to compare conventional ground survey data to LiDAR-derived measurements of channel shape, which is ultimately necessary for channel characterization and change detection purposes. This information will assist the Bureau of Reclamation in their decision-making process and determining where to specifically locate the proposed fish barriers. This project will also help determine what survey methods will be most efficient and accurate to use in the future. Thanks for listening.